Okay, this video is going to be about horizontal projectile motion. So in class we've talked about vertical projectile motion, where an object gets thrown straight up in the air and it comes straight back down. And we know that there are certain things that are always known about that situation, namely that the acceleration is always going to be g, or that negative 9.8 meters per second squared. Okay, so this is something that's thrown straight up. With horizontal projectile motion, we're in a little bit of a different situation. This is an object that maybe it's rolling off the table and it's going forward. It's going to the right or to the left when it comes off the table. Now we know that as soon as it comes off the table, we do have gravity that is going to start affecting it by pulling it down with that acceleration of a negative 9.8 meters per second squared. So it has this parabolic path. Question is, why is it parabola? Why doesn't it go down linearly? Okay, and the answer becomes that we have to really take a look at how the velocity is changing. So if I were to throw something across the room, or let's just say I throw it level like this, okay, and I'm throwing it at somebody, maybe I'm pitching it to a catcher or something, I don't know. But as soon as I let go of it, it's going to fall to the ground. Now why? Well, we know that gravity is affecting it, and so we have something to do with that acceleration due to gravity. So if we think about all the velocity being in the horizontal direction, that means the initial velocity in the y is 0. All that velocity is in the x direction. But as soon as I let go of it, that velocity gets more and more in the y direction. Okay, why does that happen? Because of the acceleration that we already know, that little g. Okay, there's a force on it, right? But what about all the stuff that's going on in the x direction, it going forward? Okay, it turns out that there is no force, there's no push or a pull or anything that causes the motion to change in the x direction. So whatever velocity we had at the beginning in the x direction is going to be the same here, 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 and all the way down. Okay, velocity in the x is constant. Okay, which makes our life very, very easy. That means there is no acceleration. Okay, there's absolutely no acceleration. But there is acceleration in the y direction. So let's give a for example. You have a lab where you're going to have a marble that's rolling off the table, and you have to place a cup somewhere on the floor so that marble is going to go straight into the cup. Okay, it's called Shoot for Your Grade Lab. So how do we figure out what's going on? Well, if we know the height of the table, let's say the height of the table is 1 meter tall. And we'll have to know how fast the marble is traveling. So let's say it's moving 5 meters per second. It's pretty fast. Marble's probably not going to be traveling that fast, but say it's moving 5 meters per second. That means if we could figure out how long it takes to fall, then we would know this distance. How do we know that distance? Well, because in the x direction, this is distance in the x, velocity is related to distance and time by that simple equation. Okay? Because there's no there's no acceleration. We can use that. So we know the velocity, we're looking for distance. The thing that we need is time. Well, what is it that's going to affect how much time we have? Well, if the object comes off the table, then it has the same amount of time to go forward as what it does to fall. So the time is related to the height that it falls. Okay, and we actually already know how to kind of tackle that. We know that it falls, and as it falls, it accelerates, and that acceleration is g. And we know that the distance that it falls is 1 meter. We also know that its initial velocity in the y direction is just 0. Why is it 0? Because all of this 5 meters per second is in the x. It's in the going straight off the table. So that means that the initial velocity in the y is 0. All right, well, let's think about this. We have an acceleration, we have a distance. Sometimes we call it x. And this time I'm actually going to call it y. So let me erase that. Okay. I'm going to call it y just to differentiate the fact that it is in a vertical distance, not a horizontal. And we have an initial velocity. So if we think about the equations that we have to try to figure out the time, then one might pop out at you as being x is equal to VOT plus 1/2 a t squared. Okay, less than 0. Now, what also makes our life easy is the fact that, hey, that initial velocity is 0. That whole thing goes away. Now, I'm using y to differentiate from the horizontal distance. This is vertical distance, so I'm going to change that to a y. So now we're just left with an equation that says y is equal to 1/2 a t squared. Okay. Now we got two equations that have t in it, so maybe we can solve one of them for t and plug that information into the other one. So 1/2 a t squared is what y is equal to. We know y, we know a, we can solve for t, so let's try to do that. It'd be 2y is equal to a t squared. T squared is equal to 2y divided by a. So t is going to be the square root of 2y divided by a. So we put that information in, square root of 2 times 1 meter divided by 9.8 meters per second squared, and you could plug that in your calculator. Okay, you might be thinking, why isn't it not negative? Why aren't we making that a negative 9.8? It's true, we should make that a negative, but if we're falling down, then we should also make the 1 meter negative as well. So the negatives will cancel out, it doesn't really even matter. Okay, so plugging this in, we get t is equal to plus or minus 0.45 seconds. Why is it plus or minus? Because it is a quadratic, right? It's a square root. But in physics, there's always physical meaning behind our things, so we're really just going to take the plus value of this. So it's 0.45 seconds. Well, if that's the case, then we can come back here and go, okay, we know the velocity it's traveling at 5 meters per second. We know the time it's now going to take to fall. It's 0.45 seconds. So we should be able to figure out a distance, right? And I have this equation wrong. I just realized that. This should be distance divided by time. Velocity is distance divided by time. And what I was thinking about, going ahead of myself, is that distance is equal to velocity times time. So hopefully that didn't mess you up too much. So if we know the velocity is 5 meters per second, we know the time is 0.45 seconds, then the distance that we have to put this out is 2.25 meters. And that's how far the marble is going to go before it hits the floor. Okay. So notice how we had to break this apart. We had our horizontal section, which was everything in green. Then we have our vertical section, which is everything in red. Okay. Vertical, horizontal. Vertical, we know that acceleration is the negative 9.8. Horizontal, there is no acceleration. In the vertical, we had an initial velocity of 0. And the horizontal, our initial velocity is constant, whatever the value is that it gave us. In this case, it was 5. In the vertical, we can use the fact that the distance that something falls is related to 1/2 at squared. Why is it not the rest of the formula? That comes back to the fact that the initial velocity is 0. Over here, we can use the fact that distance that something travels is velocity times time, because there is no acceleration. So these two equations are related to each other, and they're related by their use of time. The time it takes for you to go forward is the same time it takes for you to go down. Okay, that's horizontal projectile motion. I want to ask you a question before I let you go. Let's think about this example a little bit further. The value that we calculated, the 2.25 meters, that's from the table to the bottom of the cup, right, where it is on the floor. Do you think, and I'm going to leave this as a question on the survey, do you think that we would actually have to take into account the height of the cup to make sure that the marble does not hit the side of the cup? And if so, how do you think we're going to take advantage of that? How do you think that we're going to take account for the height of the cup? And also, should we take into account the size of the opening? Okay. See you guys next time.